For 50 years, building a giant spaceship that could fly to orbit and return home to fly again was considered impossible. The physics of space travel meant the fuel needed to land would weigh more than the money saved by keeping the rocket. Extreme heat during the return trip would destroy the delicate parts needed for a second flight. NASA tried to solve this with the space shuttle, but each flight still cost over $1 billion and required months of repairs. Experts in the industry said the math of reuse for a heavy rocket simply did not work because of the weight of the fuel and the heat of the air. Then SpaceX built Starship and changed the rules of engineering. Here is how they made the impossible routine. The core problem was always weight and heat. In rocket science, every pound counts. If you want to land a rocket, you have to carry extra fuel to fire the engines during the descent. Carrying that extra fuel makes the rocket heavier, which means you need even more fuel just to get off the ground. This is what engineers call the tyranny of the rocket equation. It is like trying to drive a car across the country, but the gas tank is so big that there is no room for the driver or the luggage. For a long time, the only way to get to space was to build a rocket, use it once, and let it fall into the ocean. This made space travel very expensive. It was like buying a new Boeing 747 for every single flight from New York to London and then crashing the plane into the water once the passengers got out. Nobody could build a business that way. The heat was an even bigger wall. When a ship comes back from space, it is moving at 17,000 miles per hour. That is about 25 times faster than a bullet. When the ship hits the air, that air turns into a wall of fire called plasma. The temperature can reach 3,000 degrees Fahrenheit. Most metals start to melt or get soft at half that temperature. The space shuttle used thousands of ceramic tiles to stay cool, but they were fragile and often fell off. If even one tile was missing, the heat could burn a hole through the wing. This made the shuttle very hard to maintain. It took thousands of workers and months of time to get it ready for another flight. People said that until we found a magic metal that does not melt, a fully reusable ship was a fantasy. Early versions of Starship seemed to prove the critics right. We watched as early test ships reached high altitudes and then crashed into the ground. Sometimes the engines would catch fire. Sometimes the fuel tanks would crumple like a soda can. These early ships, called version 1 and version 2, were learning tools. They were made of stainless steel, which was a strange choice at the time. Most modern rockets are made of carbon fiber or special aluminum. SpaceX chose steel because it is cheap and it can handle high heat much better than other materials. But even with steel, the ships were struggling. The flaps that steer the ship were getting burnt. The engines were messy and had too many pipes that could leak. It looked like the dream was hitting a ceiling. Here is how they actually did it. The breakthrough came when SpaceX moved from the older designs to version 3, specifically with the ship known as Ship 39. This was not just a small update, it was a total rethink of how a giant spaceship works. The first big change was the Raptor 3 engine. Older rocket engines are a mess of wires, sensors, and pipes on the outside. Every one of those pipes is a place where a leak can start. If a tiny vibration cracks a pipe, the engine explodes. The Raptor 3 changed the game by putting all those pipes inside the metal body of the engine itself. They used a process called 3D printing to grow the engine out of metal powder. This allowed them to hide the plumbing inside the walls of the engine. It made the engine look like a solid, smooth piece of art. Because the pipes were hidden inside the metal, the engine became much tougher. It could handle more heat and more pressure without breaking. This new design also made the engine lighter and more powerful. One Raptor 3 engine can push with 280 tons of force. That is enough power to lift a large Navy ship out of the water. By making the engine simpler, SpaceX made it safer. They removed the parts that usually break and replaced them with smart engineering. A Raptor 3 engine has about half as many parts as the older versions. In engineering, the best part is no part. If a part does not exist, it cannot break, it cannot leak, and it doesn't cost anything to build. This is how they solved the engine problem that had stopped other reusable rockets for decades. The next part of the breakthrough was the structure of Ship 39 itself. Earlier, ships used a lot of internal ribs to stay strong. These ribs were welded to the inside of the steel skin to keep the ship from collapsing under the weight of the fuel. But those ribs added a lot of weight. For Ship 39, the engineers changed how the ship was put together. They used a new type of steel alloy and changed the way the tanks were shaped. This allowed them to make the ship taller and stronger while actually making it lighter. Ship 39 is taller than the older versions, which means it can carry more fuel and more cargo. Being able to carry 100 tons to space is a huge win. That is about as heavy as 15 fully loaded pickup trucks being delivered to orbit in one go. The heat shield was also redesigned to be much tougher. On older flights, the black tiles on the belly of the ship would often crack or fall off. For Ship 39, they added a second layer of protection underneath the tiles. This backup layer acts like a fireproof blanket. Even if a tile gets hit by a piece of ice or shakes loose during the shaking of the launch, the ship stays safe. They also changed the way the tiles are attached so they can handle more vibration. The flaps, which act like the arms and legs of the ship to help it steer, were also moved. On older ships, the hinges of the flaps were exposed to the heat of re-entry. On Ship 39, the hinges are tucked away or protected by new shields so they do not melt. This means the ship can steer through the fire without losing its ability to move. Another key to this victory was the way the ship lands. Most rockets land on legs, but legs are heavy and they take up space. SpaceX decided to do something that sounded like a movie trick. They decided to catch the rocket in mid-air using giant metal arms on the launch tower. These arms are called chopsticks. By catching the rocket, they can remove the landing legs from the ship entirely. This saves a massive amount of weight. Every pound of landing leg they remove is a pound of cargo they can take to the moon. Catching a building-sized rocket with giant metal arms requires incredible precision. It is like trying to catch a falling pencil with a pair of tweezers while you are running. But because the Raptor 3 engines can change their power very quickly, the ship can hover and move with the precision of a drone. This technical mastery has led to a massive lead in the global space race. The scoreboard shows a clear winner. In the last year, SpaceX launched more rockets than every other country and company on Earth combined. They are flying about once every 2 or 3 days. That is more than twice a week, every single week of the year. For comparison, the United Launch Alliance only launched 3 times in that same year. SpaceX is moving at a speed the industry has never seen before. This frequency allows them to test new ideas much faster than NASA. If a part breaks, they fix it and fly again in weeks. Other programs take years to study a single failure. This speed is why Starship went from a drawing to a flying ship in less than 5 years. The cost difference is one of the most important parts of this story. A single launch of the NASA SLS rocket costs about $4.1 billion. That is billion with a B. That is enough money to buy everyone in a large city a new car. For that price, NASA only gets 1 flight, and the entire rocket is thrown into the ocean. Your tax dollars are being spent on a system that cannot be used again. Starship is designed to cost about $10 million per flight once it is fully working. Let's look at those numbers. One SLS launch costs 410 times more than one Starship launch. That same $4.1 billion could pay for 410 Starship launches. SpaceX could launch Starship every single day for more than a year for what NASA pays for one SLS flight. When you are trying to build a city on Mars, those numbers are the difference between success and failure. Boeing has also struggled to keep up with this new way of working. Their Starliner spacecraft was built to take astronauts to the space station. However, the program has faced years of delays and software failures. During its first test flight, the ship's internal clock was wrong, and it went into the wrong orbit. It took years to fix these basic problems. Meanwhile, the SpaceX Crew Dragon has already flown many successful missions. The contrast is very clear. One company uses a slow and expensive method that often results in mistakes. The other uses a fast method that learns from every flight. Boeing's problems show that the old way of building spaceships is too slow for the modern world. The world is moving toward fast, reusable machines, and companies that stay with old designs are being left behind. China is the only other player moving with real speed. They have seen what Starship can do and are trying to build their own version. The Chinese space program has built heavy rockets and is testing how to land them. They are very good at hitting their deadlines. They built their own space station on time and have sent robots to the far side of the moon. However, they are still years behind the engine technology of the Raptor 3. They are capable, but they are still using older designs for their fuel systems. The gap between the US and China is getting smaller because of NASA delays, but SpaceX is making that gap wider again. As long as Starship continues to improve, the US will keep its lead in how much we can build in space. The success of Ship 39 also proves that the choice of materials was right. When Elon Musk first said they would use steel, many people laughed. They said steel was too heavy and belonged in the 1950s. But steel has a secret advantage. It is very good at handling heat. Carbon fiber rockets are light, but they start to weaken at just 300 degrees. Steel stays strong even when it is glowing red. This means the ship does not need as much heavy insulation to stay safe. Because they used steel, they were able to build a giant factory in Texas to mass produce these ships. They are not building one ship at a time like a custom car. They are building a fleet of ships like an assembly line. This is the first time a company has treated rocket building like building a fleet of trucks. This is a victory for strategic intelligence. Instead of trying to build the perfect ship on paper, SpaceX built a ship that was good enough and then tested it until it broke. They found the limits of the engines and the tiles by pushing them to the edge. This information allowed them to design the Raptor 3 with 50% fewer parts than the Raptor 2. By removing parts, they removed the things that fail. This is technical mastery. It is the ability to make a complex problem simple. The results speak for themselves. Ship 39 is more powerful, lighter, and more reliable than any spaceship ever built. It is the machine that turns the impossible into a regular Tuesday. The future this creates is huge. If you can launch 100 tons for $10 million, the moon is no longer a distant dream. It becomes a place where we can actually build things. We could put giant telescopes in orbit that are as big as a football field. These telescopes could see the very first stars that ever formed. We could build power stations in space that beam clean energy down to Earth. We could even build a permanent base on the moon with houses and labs. Currently, it costs about $20,000 to send just 1 kilogram of stuff to space. Starship aims to drop that to less than $100. This change is what makes going to Mars possible. You cannot build a city on another planet if it costs billions to send a box of tools. You can only do it if the cost of the trip is low. The competition is now trying to catch up. Other countries are realizing they cannot rely on their old, expensive rockets. Europe is trying to redesign its Ariane rocket to be more competitive. Russia is struggling to keep its old Soyuz rockets relevant in a world that wants reuse. Even Blue Origin is still trying to get its first heavy rocket into orbit. While these other groups are still drawing designs and building prototypes, SpaceX is already flying its third version of the hardware. This shows a clear hierarchy of competence. The people who take the most risks and fly the most often are the ones who end up leading. The time for talking about space is over, and the time for building is here. History shows us that whoever has the best way to move things wins. In the 1800s, it was the railroads that changed the world. In the 1900s, it was the airplanes that made the world smaller. In this century, it will be the heavy-lift, reusable rockets. Starship is the railroad to the stars. By making it reusable, SpaceX has turned a one-time use firework into a reliable cargo plane. This is the victory that will define the next 50 years. We are no longer limited by how much a government is willing to spend. We are only limited by our own imagination and our ability to build once we reach the stars. There is also a sense of justice in how this is happening. The companies that refuse to change are losing. For years, big contractors took billions in money without making their rockets better or cheaper. They stayed with old designs because it was easy and it made them a lot of money. SpaceX challenged that system and proved that you can do more with less. This pressure is good for everyone. It forces other companies to work harder and stop wasting money. It protects the future of space travel by making it something we can afford to do every day. We are seeing the end of the time when space was only for a few people. We are entering the time when space is open for everyone. Ship 39 is not just a better rocket. It is the proof that hard problems can be solved with enough work. The engines are cleaner and stronger. The body of the ship is lighter. The heat shield is tougher. Every lesson from the crashes of the past is built into the steel of this new ship. The impossible did not just go away on its own. It was beaten by better engineering and faster testing. As Ship 39 prepares for its next flights, the world is watching a major change. What used to be science fiction is now becoming a normal part of life. The next few years will be exciting. We will see Starship landing on the moon for NASA's Artemis program. This will be the first time humans have walked on the moon in over 50 years. This mission only works because Starship is so big. It can carry the water, air, and food needed for a long stay on the lunar surface. No other rocket can carry this much. Starship's cargo hold is so big that you could fit the entire Hubble Space Telescope inside it with room left over. This changes how we do science. We do not have to build tiny, expensive tools anymore. We can build big, strong machines and send them up by the dozen. We are watching the start of a new age. The Raptor 3 engine is the heart of this change. By removing the messy pipes and sensors and putting them inside the metal, the engine can now work better and stay cooler. This is smart engineering at its best. The ship is becoming more like a modern car that can tell you if something is wrong and fix it. This level of mastery is what we need to land on planets where there are no repair shops. It is the key to making humans a multi-planet species. The impossible became routine because SpaceX did not accept the old rules. They didn't just build a better rocket, they built a better way to build rockets. Hundreds of successful landings have shown that reuse is the only way forward. While others are still stuck in meetings, Ship 39 is showing us the future. The era of the throwaway rocket is over, and the era of the Starship has begun. Soon, these flights will be so common that people won't even look up when a 40-story building lands itself on the ground. This is the transformation of space from a rare event into a part of our daily life. The moon is now within our reach, and Mars is the next stop on our journey. SpaceX didn't just land a rocket, they made it routine. Over 200 successful landings have occurred while Boeing Starliner struggled and competitors haven't reached orbit. The impossible became infrastructure, and now Starship aims to do the same at a much larger scale. This turns the dream of Mars from a story into a real engineering project that we can solve.